Next, we're going to look at two specific types of sequences. So last time we just introduced sequences and we saw they're just a list of numbers and it goes on and on. So in this section, we're going to introduce arithmetic sequences. And the simplest way to generate this type of sequence is to start with the number a and then add to it a fixed constant d over and over again. So if I start my first term in the sequence, a1, so a1, first term in the sequence is just going to be a. Then a2 is going to be, I add a fixed constant d, so it's going to be the first term a plus d. a3 is going to be, well, I add another d to the previous term, so it's going to end up being a plus d plus another d, so a plus 2d. And then a4 is going to be a plus 3d. I add another d to the previous term. So the number a is the first term, and d, the constant term that we are adding over and over, is called the common difference of the sequence. So in general, the nth term of a sequence is going to be given by this. I add n minus 1d. So let's recap. So a1, it was just a. a2 was a plus d. So I can think of a plus 1d. a3 was a plus 2d. So notice a4, again, it was a plus 3d. So when n was 4, I added 3d. When n was 3, I added 2d. So it's always one less d's than the term I'm looking at. So in general, an is going to be the first term a plus one less than n, so n minus 1d. So this is how we get the general term of an arithmetic sequence. So let's look at an example. So let's find the common difference and the first 6 terms, the general term, and the 300 term of the arithmetic sequence. So if you look at this arithmetic sequence, the first term is 13, the second term is 7, the third term is 1, the fourth term is negative 5. So is this an arithmetic sequence? Well, what's the difference between 7 and 13? So d, the difference between the first 2 terms, so a2 minus a1, is going to be 7 minus 13 is negative 6. So if I add negative 6 to 13, I get 7. If I add another negative 6 to 7, I get 1. If I add negative 6 to 1, I get negative 5. So this is indeed an arithmetic sequence. So a, our first term, is 13. a2 is going to be a plus 1d, and let's check that. A is 13 plus 1 times d, we found that is negative 6. And indeed, 13 minus 6 is 7. a3 would be a plus 2 times d, so let's check that. A is 13 plus 2 times negative 6. 13 minus 12 is indeed 1. And then a4 is a plus 3d. So it's going to be a, which is 13 plus 3 times negative 6. Negative 18 plus 13, that's negative 5. So let's find the first 6 terms. We already have the first 4 ones. So a5. a5 is going to be a, the first term, plus 4d, according to this formula right here. When I substitute n equals 5, I get a plus 5 minus 1, that's 4. So a is 13 plus 4 times d. We found that the common difference is negative 6. So this is going to be negative 17. And then a6 is going to be a plus 5d. A was 13 and d was negative 6. So it's going to be, this one is negative 11 and this is negative 17. So we found the first 6 terms. Let's find the nth term. So an, well, it's just going to be a plus n minus 1d. So I gotta just substitute where a is and what d is, and that's going to give me an. So an is going to be 13, that's my a, plus n minus 1 times d, which is negative 6. So this is an. And then finally, the 300th term, so a300 is just going to be, according to this formula for the general term an, it's going to be 13 plus n is 300, so it's going to be 300 minus 1 times negative 6. And then if you calculate this, you get negative 1781. So this is how arithmetic sequences work. You start with the number a, and then if you add a common difference, so if you add a constant term each time, so from a1 to a2, I just added 1d. From a2 to a3, I added another d to a2. So I can say that it's a plus 1d plus another d, but a plus 1d is a2. All right, let's do another example. So they're giving us that the 11th term of an arithmetic sequence is 52. So this is telling me that a11th is 52. And then the 19th term is 92. So a19th is 92. So from this information, we are asked to find what is a1000. So we have to think, what is a11? So in terms of the general term of an arithmetic sequence, a11, so when n is 11, we're going to have that it's a plus 11 minus 1 times d. And then a19th is going to be a plus 19 minus 1 times d. So in this case, a11, they said that a11 is 52. So 52 is going to be equal to a plus 11 minus 1 is 10, so 10d. And then in this case, a19 is given to be 92. So instead of a19, I'm going to write 92 equals a plus 18d. So if I solve this system of two equations for a and d, I will get the answer. So if I subtract this equation, subtract this from this one, it's going to be 92 minus 52 equals a plus 18d minus this one, so minus a minus 10d. So I'm going to get that 40 equals, the a's cancels, 18 minus 10, that's 8d. So that's going to give me that d is 5. So the common difference is 5. And now to find a, I just need to plug in d equals 5 in one of them. So let's see, let's plug it in here. So I'm going to have 52 equals a plus 10 times d is 5, so 10 times 5. So 52 equals a plus 50, so a must be 2. So now that I have the first term and the common difference, I can find a1000, because according to the formula, a1000 is just going to be a plus 1000 minus 1 times d. So a1000 is going to be a, which is 2, plus 999 times d, which is 5. So if we calculate this, we get that the answer is 4997. So if I have any two terms of a sequence, so if I have a11 and a19, I can find any term. So we just found the first term and the common difference, and then I can get any term because the term involves a and d. All right. There is a nifty formula for the partial sum of a sequence. So if you remember from last time, a sequence was just given by the list of the numbers and so on. But a partial sum is going to be if I add the terms of a sequence and I stop at a certain point. So if I stop at a100, for example, this is called a partial sum, and we denote it with S100. So the sequence is just listing the numbers. The sum of the sequence, if I have a partial sum, will be where I stop at a certain n. So if I stop at n is 100, the partial sum is denoted as 100 and is adding the first 100 terms of the sequence. So for arithmetic sequences, we actually have a nice formula for partial sums. So this formula this can be proved by induction, and we're going to go over induction next week. But for now, I am just saying that this is the formula for the partial sum. So if I want to add, for example, if I want to add the first 100 terms of a sequence, of an arithmetic sequence, I can do this by using this formula. So for example, find the sum of the first 100 numbers. The first 100 numbers are 1, 2, 3, 4, 5, 100. Okay? So to find the sum of the first 100 numbers, it means to find S100, which is 1 plus 2 plus 3 plus 4 plus 100. So you don't want to put this in your calculator. You want to use this formula, because this is an arithmetic sequence. What's my first term? What's A1? My first term A1 is A, right? That's how we denote it. And D, what is the common difference between any two terms? It's 1. So this is an arithmetic sequence. So according to this formula, to find the partial sum for an arithmetic sequence, you're going to say that it's equal to n, but in our case, n is 100, times the first term, in our case the first term is 1, plus A100, which is 100, over 2. So this is going to be equal to 100 divided by 2 is 50, so it's going to be 50 times 101. And that's 505. It's not 505. That's 50/50, 5,050. So the sum of the first 100 numbers is going to be 100 times 101 divided by 2. So if you look at this formula, an is this right here. So if I substitute an with a plus n minus 1 times d, then I can rewrite this formula as n over 2 a plus an. But an is a plus n minus 1 over n minus 1 times d. So it's going to be, so n times a plus an over 2 is the same as n over 2, took care of this one and that one, times a plus, if I substitute what an is, it's going to be a plus n minus 1 d. So a plus a is 2a. So then another form of this formula is n over 2, 2a plus n minus 1d. But if you just remember this one, this is going to help a lot, because you can always get this one from that one. Just remember the nth partial sum of an arithmetic series is going to be n times the average of the first term and the last term. So first term plus the last term divided by 2. What about find the sum of the first 50 odd numbers? So this will be find the sum of 1 is the first odd number, and then 3, 5, 7, 9, 11, and so on. So first of all, notice this is an arithmetic sequence with a equals 1, and the common difference, well, 2. The difference between 3 and 5 is 2, 5 and 7 is 2, so it's an arithmetic sequence is a equals 1 and d equals 2. So to find the sum of the first 50 odd numbers, I just need to write down the formula. So S50 is going to be times a plus a50 over 2. So I just use this formula with n equals 50. So this is going to be 50 times A, the first term is 1, plus A50 over 2. So if I just find what A50 is, I am going to get the answer. So A50, remember the general term of a sequence, of an arithmetic sequence is going to be, it's this. It's the first term times n minus 1 times d. So A50 is going to be A plus n minus 1, but n is 50, so 50 minus 1 times d. And I already have that A is 1 and d is 2. So A50 is going to be A, which is 1, plus 49 times d, which is 2. So this is going to give me A50 is 99. Then I'm just going to plug in 99 for A50 and get the sum of the first 50 odd numbers. So 50 times 1 plus 99 over 2. So this will give you 2500. So this S50 is 2500.